Hello everybody! Today I'm going to explain how to solve the problems E and F from the AtCoder Beginner Contest 167. In the problem E, we are given n blocks and we need to color them in one of the m colors such that there are at most k pairs of adjacent blocks that are painted in the same color. And we need to print the answer modulo some big prime number because the answer can be huge. In order to solve this problem, we need to redefine the second condition. The second condition tells us that there can be at most k pairs of adjacent blocks that are painted in the same color. This means that if we have, let's say, the array painted such that in every pair of positions which are next to each other, different colors. In this case, we are going to have n components, and for each pair added, the number of components is going to drop by 1. So we can reduce the problem to finding the number of ways to have an array with exactly n minus k components, obviously by considering the positions where the components are going to change as well. I'm going to explain in the sketchpad in more details this. So, as I said, we have n, m, and k. And if, let's say, our array has the same color everywhere, we are going to have just one component. Or if any two positions have different colors, we are going to have exactly n components, as you can see here. Now, if we are going to add one pair, the number of components is going to drop by 1. Let's say we have something like this, where A and B are colors. If this pair had a different color, or let's say even better, this character had a different color, then the number of components would have been bigger, unless that character would have had the color equal to B, which in this case the number of components would have been the same. So basically, we can now do the following thing. For the first component, we can fix the color as we want. So we are going to have m ways. For each of the next components, we are going to fix the color as we want, but we can't fix it in the color of the previous component. So we are going to multiply the answer for some number of fixed pairs with m minus 1 raised at the n minus k minus 1. Why n minus k minus 1? Because there are n minus k components and the first component can be fixed as we want. Now we need to also fix the positions where we are going to have the pairs. Since in an array of length n, there are n minus 1 possible positions where we can do this, as you can see here, we are going to have n minus 1 choose k minus 1, or even better, k. So why n minus 1 choose k? Because this is the number of ways to choose k positions from the number of possible positions to make the components the same color. The formula for n choose k is n factorial divided by k factorial and divided also by n minus k factorial. Now this is the answer for a certain k. All we have to do is to sum up the answer for each I from 1 to k. Now I'm going to move to the implementation part where I explain what I did in more detail. Here I'm pre-computing the factorials and the modular inverses of the factorials from 1 to n, since we are going to need them in the n choose k formula. And the computation of the powers and the n choose k can be done using modular exponentiation and, in this case, some multiplication. Now for each number of possible pairs from 0 to k, the number of components is going to be equal to n minus I, and the coefficient, as I said, the gain we are going to add to the answer is going to be m multiplied by m minus 1 raised at the number of components minus 1, and we need to always use mod, because if we forget to use mod once, then the answer would overflow, and this is wrong. Last but not least, we are required to multiply the answer by n minus 1 choose I. And now we have to sum up the answers to get our desired answer. Now let's move on to problem F, bracket sequencing. In this problem, we are given n brackets, and we need to find if we can arrange the bracket sequences in some way such that we can get them balanced. We can get a balanced bracket sequence. And we are given the rules here in the statement. This problem is kind of a classical problem which can be found in educational code forces around. And in order to be able to solve it easily, we need to make some observations. Firstly, we need to reduce the strings, because if we have something like this, we can get rid of some of the bracket pairs, such as this one, or this sequence. This will help us reduce the string, and after reducing the strings, you can observe that there are exactly 3 ways a string can end up with. The first way is something like this: only open brackets everywhere. The second form is the opposite of the first form: only brackets closed everywhere. And the third form is a concatenation of these 2 forms, starting with some closing brackets and then ending with opening brackets. It's quite easy to observe that if we add here a closing bracket, then we are going to reduce one pair, or if we add here an opening bracket as well, and same for these 2 positions. Now all we have to do is to count the number of strings which have full open, full close, and closed then some open. For the first 2 parts, the casework is quite easy. We are just going to keep 2 integers which tell us the number of open brackets in a row and the number of closed brackets in a row. As you already may have noticed, the harder problem is to deal with this string, because it has both closing brackets at the beginning and then opening brackets at the end. And we need to add them in such a way that we are not going to run out of open brackets. In order to deal with this, I'm going to find for each string how many closed brackets and how many open brackets are there. Let's say for some string we have the pair 2, 3. This means that the string starts with 2 closing brackets and ends with 3 opening brackets. In my solution, I have sorted the pairs in the increasing order of the second number minus the first number, and then I'm matching the second number, the ones with the biggest number, as in a difference bigger or equal than 0. Why is it optimal to at first match the strings with the bigger number of open brackets? Because this can lead us to more open brackets, and then in case we would have many closing brackets, we can match them all. In order to do this, I have added them in a multiset, and in case I can take something, I am desiring to take the one with the least amount of closing brackets. Why is this true? Because if we would take something with a bigger number of brackets, then we would lose some options, and maybe we won't be able to match the full sequence of brackets. So for the strings with difference bigger or equal than 0, I'm just trying to take the one with the smallest number of closing brackets. Now for the strings with the difference less or equal than 0, I'm greedily going from the biggest differences to the smallest differences. And for some pair, I'm trying to see if I can go to add it. And if I can't add it, then the answer is no. Otherwise, the answer is yes. So I'm going to move on to the implementation since there are quite a few cases. As you can see here, I'm reducing the string using a double-ended queue. It can be also reduced using a stack. And based on the cases, I have three cases. Either the string is full of opening brackets, either the string is full of closing brackets, or the one with both closing and open brackets. Since the differences can be negative and we can't store positions negative positions, I have added to the difference 1 million in order to make the differences positive. Now for some difference, I am adding the pairs in a multiset, namely the positive differences. And while we still have some differences, then we can just check if we can actually add it, the one with the least number of closing brackets. If we can't add it, then the answer is no. Otherwise, we are just trying to add it. If we did this, then we have to check if for the other strings we can add them as well. The checking can be done in the same way. If the difference between the number of open brackets and the number of closing brackets is less than 0, we can't add it, and the answer is no. Otherwise, we are going to do the subtraction. Last but not least, we need to deal with the second kind of strings, the ones with just closing brackets. If after all of this casework the difference is 0, then the answer is yes. Otherwise, the answer is no. As you can see, these problems were quite challenging for an AtCoder Beginner Contest, and also quite difficult to come up with the solution unless you are really experienced and careful. So they are quite worth up solving. If you liked watching this video, please like the video, subscribe to the channel, and press the bell button in order to be the first one to get notifications about the new video. Also, you can join the Discord server for more nice content. Until the next time, stay safe, stay healthy, good luck, and goodbye.